Lecturers talk while other people are sleeping. No. My students are not sleeping. And I'm not sleeping in front of the class. So let's hear other words. Interesting. Doing a demonstration. Yeah, let's hear some others. Listening. Very good. What else? Taking notes. What else? From the back. Watching. Listening. Well, are they really practicing there? I don't think so. What else? This is my lecture. Confusing. Okay. I'm confusing the students. Boring? I didn't get it. Boring. My lecture. This is me. This is me. Okay, so notice that the verbs that we've heard so far either refer to me, the instructor, or to them, the students. Listening, but they're listening, I'm not listening. Talking, I'm talking, but they're not talking. Sleeping, well, they're sleeping, but I cannot sleep. I have to lecture. Is there a way that we can describe the two together, them and me together, because we're both there? What is it that is happening between them and me together? Work? Yeah. Give me the verb again. Yes. Communicating. Very good, communicating. But when I think of communicating, I think of one way and back. I don't think there's back there. There's only one way, really, right? Discussing, same thing. What? Back. But we are discussing right now, but in a normal lecture. The students are, passive. They don't want to talk. When I ask them, does anybody have a question? Anybody? They look down. They don't want to make eye contact. So, communicating, discussing, we're getting closer, but we're not exactly where I want to be. What is it that is happening? Thinking? I would hope so, but I can't tell because they're just sitting there. Showing, talking, but now we're talking again about just me, right? I want the two together. Well, interacting, but interacting, again, is a two-way process. Is this a two-way process? I don't think so. So it's not like this, it's just like that. Lectures focus on the transmission of information. That's what a lecture actually is. It's a way of transmitting information. And you know what? My students had actually told me that, and I had ignored it. You see, when I started teaching, a long time ago, 31 years ago, at Harvard, I did not ask myself, how am I going to teach? I should have asked myself, how am I going to teach? But the question did not come up in my mind. I was going to do to my students what my professors had done to me. I think we all tend to do that. The question that I did ask myself was not how, but what. So I went to a colleague who had taught the course before, and I asked him that question, and he said, oh, in this course, we use the book by Halliday and Resnick. I don't know, maybe you know that book. It's been a classic for many, many years. Now, I don't know how it is in Thailand, but in the United States, students buy the textbook for their courses. In where I came from, in Holland, we didn't buy the book. Why buy the book if the professor is giving you the content of the book in the class? Do students here buy the book? Do they actually buy the book? Yes or no? Do students buy the book? They actually purchase the book for the introductory courses? Mostly, okay. Well, okay, so I was told in the US they purchase the book. So I had to call the bookstore and make sure that they had enough copies of Halliday and Resnick in stock. So I went to the bookstore and I said, be sure that by September 15, you have 150 copies of Halliday and Resnick. And as I walked back to my office, I thought, wait a minute. If the students have the book and I have the same book, then what do I do in the classroom? So I went to my colleague and I knocked on his door and I asked him that question. And he said, don't worry, there are lots of different physics textbooks. And he showed me many books that he had collected. And I started to look. And very quickly, I found the perfect book. It was perfect for two reasons. One, it was different from Halliday and Resnick. So I was not just simply presenting the content of the book that the students had bought. But that was not the important point. The important point, number two, was the book was no longer for sale. The students couldn't buy the book. So for every lecture, I spent 10 hours to prepare my lecture notes. And in class, I would either project the lecture notes on the overhead projector, or I would write them on the board behind me. And because my lecture notes were different from the book, at the end of class, I gave my students a copy of my lecture notes. So as they walked out, they could grab a photocopy of the lecture notes. You know what happened? What happened was that at the end of that year, about half a dozen students wrote on their student evaluation. Do you have student evaluations here too? Yeah? At the end of the semester? Okay. So they wrote on their student evaluation, Professor Mazur lectures straight from his lecture notes. Hello? I mean, did they want me to make another set of lecture notes to lecture from that was different from the lecture notes I handed out to them? I was angry. But you know, the students had a point. They were right. I was focusing on the transmission of information. Now, if you go around the world, and I visit many places around the world, our learning spaces, our classrooms are all like this. Students facing forward. Here's Harvard. Here's Chulalongkorn. You can go to any university in the world and you see the same scene over and over again. So we could ask ourselves, is that what education is? Is education simply the transfer of information? I mean, it's not a crazy question, right? Because if you go and look at all the classrooms on this campus or on my campus or on any other campus looks like this, with people talking to students and students taking notes. I once heard somebody describe the lecture method as a process whereby the lecture notes of the instructor get transferred to the notebooks of the students without passing through the brains of either. They just, just the transfer of the information. So let's actually have a vote. There's no question on the screen, but we'll vote. I'm going to show here. Okay. If you believe that education is just the transfer of information, press 1. If you believe education is more than just the transfer of information, press 2. So 1, education is just the transfer of information. 2, education is more than just the transfer of information. A few more seconds. 5, 3, 2, 1, and 0. I'm happy to see that almost everybody agrees that education is more than just the transfer of education. I have a warning for this person. You are going to lose your job. Because let us imagine for a moment that education is just the transfer of information. Right? I know that most people disagree with that statement, but let's imagine for a moment that education is just the transfer of information. If education is just the transfer of information, what would be the logical thing to do in the 21st century? What would be the logical thing to do? We live in an information age, so if education is a transfer of information, what would be the logical thing to do? It's actually already happening. Think about it logically. Education is just a transfer of information, so what should we do? Videotape the lecture and let the students watch it. Right? I mean, what would you lose? Right? Take the best Thai professor of physics, the best American professor of physics, the best French professor of physics, and put it on the internet. It's already happening. What would you lose by doing that? Of course, we'd lose our jobs, right? But in addition to our jobs, what would you lose by filming all the professors like me there and putting it on the internet? What would you lose? What would you lose in addition to our job? It's not a difficult question. What would you lose? Nobody? Come on. It's Monday. It's not Friday. Don't be afraid. What would you lose by taking all the professors here at Chulalongkorn? 1 year, we're going to videotape all their lectures. We put it on the internet, and then we fire them all. Gone. Why not? And we fire me too at Harvard. We film all the Harvard professors, we put it online, fired. What would you lose? I don't hear. Interaction. Interaction. But how much interaction is there in a lecture? I am trying very, very hard to interact with you. You don't want to interact with me. Huh? We have a gain. Exactly. I totally agree with that. By putting it on the internet, we actually gain something. I'll get to that in a second. First, about the interaction. Do we actually lose interaction by putting it on the internet? No, I don't think so. You see how difficult it is to interact in a room like this. It is very difficult to interact. People sit down. Some people sleep. Some people just take notes. Some people listen. But it's very hard to speak up and to interact in a space like this. So I think that by putting it online, we would not lose anything. Because what you can do online is pretty similar to what you can do in the classroom. However, we would gain something, as this person here just pointed out. We would gain a number of things. One, students could look at it whenever they want. But that's not the only gain. The other gain is that you get actually time to think. You see, in a lecture, it is very difficult to think because the person in front of you is speaking. Have you ever had a student in your class raise his hand and say, "Professor, could you please be quiet for 5 minutes? I need to think." It's never happened in my classes. But you have to admit, if you need to think, you cannot listen at the same time. You cannot say, because if you do that, your mind wanders and you're no longer listening to the information. So why is it so difficult to think in a lecture? Because if you think, you're missing the information coming in. So most students do not think, they just write down. So I think that if education were just a transfer of information, then we are going to all lose our jobs. But I'm happy to see that 98% said no. Education is not just the transfer of information. So let me now ask the 98% of you who said no, what more than just the transfer of information is education? What is it more than just the transfer of information? Think about the little exercise that we did. Practicing. You need to do something. It's not enough to open your skull, put the information in, close your skull, and then regurgitate the information on the exam. Even though a lot of education is like that. Students memorizing information, and then on the exam, they give the information back. That's not what education really is. So let's turn for a moment to problem solving, because what is happening, and it took a while for me to discover that. What happened when I taught that way was that my students were actually not really learning. After teaching for 7 years, I read an article about the Force Concept Inventory, FCI. How many of you know about the Force Concept Inventory? One person, 2, 3, 4, 5. Good, okay. A number of people know about the Force Concept Inventory. Let me describe what the FCI, the Force Concept Inventory is. It's a multiple choice test that with words only tests students' understanding of Newton's laws. Let me give you an example of a question. A heavy truck and a light car collide on the highway. Boom. 1. Is the force exerted by the heavy truck on the light car larger than the force exerted by the light car on the heavy truck? 2. Those two forces are equal to each other. 3. The light car exerts a larger force on the heavy truck than the other way around. Now, all students in introductory physics all around the world can recite Newton's third law. Action is reaction. Or the force of object 1 on object 2 is equal in magnitude to the force of object 2 on object 1. F1, 2 equals F2, 1. Right? I mean, all students can say that. But something really interesting happens when you replace 1 by heavy truck and 2 by light car. They all forget about Newton's third law, and they're all convinced that the heavier object exerts a larger force on the light car than the other way around. I read that article, and I thought, no way. Not my students. Not Harvard students. I don't know about you, but I learned that in high school. And most of the students at Harvard have an advanced course in physics. So I thought they would have learned this a long time ago. But anyway, I'm a scientist, so I know not to make claims without data. So I thought, I am going to show that in my class at Harvard, students know how to answer these type of questions. So I gave the test to my students. And within 5 minutes, one student raised her hand and she said, Professor Mazur, how should I answer these questions? According to what you taught us, or according to the way I usually think about these things? That's not funny. I had no idea how to answer that question. And by the time the test had been completed, it became clear that my students were not really learning the physics. They were just memorizing facts and procedures. So it's not the transfer of information that's important, but the assimilation of that information, making sense of the information, having this aha moment, oh, I get it now. Let's look for a moment at something else. Look at this picture. You probably saw right away what this picture is, right? And if this picture evokes pleasant memories, then I would like to talk to you after my talk. Most people, when they see this picture, don't have pleasant memories. These are students at an exam solving problems. And I would argue that most students solving problems actually do not solve real problems. I think that the way we are assessing our students promotes memorization, and it prevents creativity. It kills creativity, actually. What is a real problem? If you have a real problem, then you usually know what the outcome is. You know where you want to get. You're baking a cake. And as you start baking the cake, you discover that you have no more flour. You have a problem. You look at your watch, it's too late, the stores are closed. You're a problem. You know the outcome. The outcome is a cake. The question is, what is the solution to getting a cake? Or let's say that you have a job interview in Hong Kong. You go to the airport. You arrive at the airport. Your flight to Hong Kong is canceled. It's the last flight. You have a problem because you have to be in Hong Kong for a job interview. Again, you know what the outcome is. You don't know what the solution is. Any problem in business or in science or in real life fits that pattern. Known outcome, unknown solution. And your task to solve the problem is to find the solution. However, when we test our students, we give them very different problems. We give them a problem where we typically ask them to apply a known procedure to find an unknown answer. Let me give an example from physics. A car is going along a road at such and such a speed, blah, 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 and so on, and then the car hits the tree, and then it asks, at what speed did the car hit the tree? And the student thinks, what are the equations that I've memorized that allow me to calculate velocity? There's this equation, there's that equation, there's that equation. The first one doesn't work because I don't have all the variables. The second one works, let me put in the number. And then you calculate, and you get 4.2 meters per second. And your solution is evaluated on the answer, not on how you get to the answer. Right? I mean, the equation has been memorized, and this is what is being evaluated. Do you see the difference between these two? The top is a real problem. The bottom is a textbook problem. And I think this is very important in the 21st century because computers can do this. You don't need a human being to do this. Computers cannot do the top. Computers can do the bottom. And I predict that just as assembly line jobs have been replaced by robots, so will any job related to this type of problem solving be replaced by computers. So we really need to focus on real problem solving, not textbook problem solving. But there's a problem with real problem solving, because real problem solving is erratic. It involves failing. You try one way, it doesn't work. You try another way, it doesn't work. If you're lucky, the third way works. If you're unlucky, like Thomas Edison from the light bulb, you have to try 300 times. And students are afraid of mistakes. Why are they afraid of mistakes? Because if you make a mistake, you lose points. So in a sense, our assessment, our grading practices are incompatible with real problem solving, authentic problem solving. In a sense, grading makes it very difficult to be creative and innovative for a student. So our traditional assessment, not only our approaches to teaching, but also our approach to assessment, focus on the outcome, not on the process, even though it's the process that is important. It discourages risk-taking. It makes students risk-averse. It focuses on the individual, not on the group. Remember that picture of the students separated from each other, cut off from information? In real life, you're never isolated. You're never cut off from information. I can always look up information whenever I want. So why do we test our students without access to information? They're not going to work that way. And lastly, assessment does not mirror the future work environment. Anyway, so after I discovered that my students were not really learning, they were memorizing, I started to rethink my approach to teaching. And I realized that teaching, in a sense,